level curve of a function whose domain is in R2 for the value c is the set of points satisfying the equation f of xy equal z. So we know that we can graph a function if the domain is in R2. Remember that we need always one more dimension for the function to live in. So if the domain is R2, so we have this R2 in the domain of the function, and we need one more dimension to actually draw the graph. So we can have, for instance, a surface that looks like this. So we can actually graph a function that goes from R2 to R. But now, if we consider the values of xy such that f of xy is equal to c, so for instance, if this is a particular value c here, so then we are cutting somehow this curve by a plane at the height of c. So we are going to get some curve here that will be what is called a level curve. So let's see, for instance, a function of two variables like this one. This will be the graph of this function, pi x squared y squared divided by 2, etc. So if we have the graph of this function, so try to imagine what would happen if we intersect this surface with a horizontal plane. So will depend, the result will depend on the height where we are intersecting this surface, and that will be the different level curves that you obtain. So for instance, I'm going to intersect, let's say, at this height around here. So let's say z equals 0.4. So I intersect and I get these level curves. So two circles. So two circles would be the result of the intersection of the surface by a horizontal plane. And if you consider the collection of all the different level curves, not just for 0.4, but 0.3, 1, any possible number here, so then you will get what is called the contour plot. So the contour plot is the set of all the different level curves of the function. So here we have an individual level curve for the value of z 0.4, and here we have many level curves of the result of intersecting this surface with different height of horizontal planes. So when we combine then all the different level curves for different values of c, so what we obtain is what is called a contour map of this graph. Well, we can scale up these two functions whose domain is R3 instead of R2. The difficulty here being that we cannot graph these functions, right? Since remember that we need always one more dimension to draw the functions. So if we use the 3 dimensions that we actually have already for the domain, we will need a 4th dimension for actually graph the function. So a function whose domain is in R3 lives in R4, and so therefore we cannot actually visualize a graph of it. But we can still define the objects defined by the equation f of x, y, z equal a concrete value. And so these ones, the intersection of this graph in R4 with generalized planes is going to give us, instead of a level curve, a level surface. So for instance, let's see, we have this function f of x, y, z. See that here the domain is R3. So how do we draw this function? Well, we cannot, because we will need 4 dimensions in order to graph this function. But we can still draw the surface, the level surfaces, when we put these functions equal to something. So if we put this function equals to 1 or equals to 2, equal to 3, so then we were going to have the different level surfaces. So observe here, this is the function that we showed before, and so I'm going to do the plot of the level surface. In this case, the function equals to 1, and I obtain that the level surface in this case coincides with, looks like a sphere. So if I change here the equals to what, so we can get the level surface for c equal 3, for instance, and so we will get another drawing. In this case, we got this other sphere, smaller than the one that we got before. So it looked like here the set of surfaces, level surfaces, are concentric spheres.